Next, let's look at the 4-controller situation. 4 controllers is really just a variation of 2 controllers. To help us understand, we can first think of it as a 2-controller situation. I've created 2 controllers here to help everyone understand. See, there are 2 larger controllers in the middle. If we ignore the 4 corner controllers and just use these 2 controllers to rig the model, how would we do it? We would use these 2 controllers to apply a point constraint to it. We're already very familiar with this. And then we would use this left side controller to apply an aim constraint to the model itself. Here, we need to ensure its x-axis always points at the controller, and set the word up type to scene_up. Let's set it up. Let's take a look. We'll see it achieve the effect based on the 2-controller situation. Next, let's show all 4 controllers again, and let's analyze this. Because these 2 side controllers don't actually exist, we need to use these 4 controllers to find the positions of these 2 controllers and drive them. We can think about where the middle controller's position should be. When we move one of the left side controllers up, it's definitely going to be at a position between these 2. So look here. If I select these 2 controllers and apply a point constraint to this middle controller, this way, look, when I move one of the controllers, because it has a 50% influence on the middle controller, the middle position will be at the 50% mark between these 2 controllers, and it will create this tilting effect. If I move both controllers together, it corresponds to the effect of the entire left side lifting up. It's the same for the right side. If we apply a point constraint with these 2 on the right, and look again, when the right side moves together, it's the same effect here. And if it's just 1, it's also exactly the same as before. Okay, so at this point, we know what these 2 positions actually represent under the 4-controller setup. To simplify the operation, we can delete the 2 constraints we had. For the position, it's obvious. It's just using the 4 controllers to apply a point constraint to it. This way, they each control 25% of it. So when we move 1, it has a 25% influence. And if 2 move together, it's a 50% influence. And if all 4 move together, it's 100% moving the model up. Next is rotation. We knew from before, the x-axis always points at the middle controller. That middle controller is controlled by the 2 left side controllers. It's always at the center point of these 2 controllers. So let's create a locator, and let's rename it. Group it. Then let's snap this group to the center position. Then use the 2 controllers to apply a point constraint to the locator. This way, when we move them, our locator will always be at the center position. Next, we can delete those 2 helper controllers we created, and use our locator to apply an aim constraint to the model itself. We're still using the scene's y-axis as the up reference direction. Now let's check again. It should be exactly the same effect as before. We've achieved half the effect. The left-right effect is done. But the front-back effect isn't working yet. If we move it front and back, the position problem is actually solved. But the rotation is not solved. We can also convert the front-back into a 2-controller situation. Let's group the front ones into 1 controller and the back ones into 1 controller. If this is the situation, let's think. If we take the front controller and move it up, position-wise, it's the center point of the front and back controllers. The final conclusion should be the same as before. Ultimately, we use the 4 corner controllers to apply a point constraint to the model. The main problem is still the rotation. If the rotation direction is front-back, how do we do the aim constraint? It's actually the same. We can just have the z-axis always point at the front object, or use the negative z-axis to point at the rear object. It's all the same, as long as it satisfies the effect of being on this line. But what's the problem here? The model already has an aim constraint. We're requiring its x-axis to point to the left side center. So how can we require its z-axis to point to the front center at the same time? If we recall the aim constraint, we should remember the aim constraint requires us to define the orientation of 2 axes to get a final rotation value. We've been using the word y-axis as the up vector. This is clearly not allowed for rigging. We've already used the x-axis as the aim vector to define its orientation. So next we can take that up vector, which was using the y-axis, and we can change it. What do we change it to? We can change it to object up, using the center position of the two front controllers as the reference object to make the z-axis always point at it. Let's try that. Let's delete the original aim constraint, then create a locator. This locator is the front locator. Snap it to this front position. Then use the two front controllers to apply a point constraint to it. Next, let's copy its name. And same operation. Use our side locator to apply an aim constraint to the model. But here we'll change our up vector to the z-axis, no longer y, and change the up object to the front locator we just created. Okay, let's create it. Now let's hide these two front back controllers. And look at the result again. Now look. Because these two locator positions are determined by the controllers, the x-axis points to the side, the z-axis points to the front. This creates an upward tilting effect. If I leave the other side, it returns to the two controller situation we talked about. And if we move the two front controllers, let's see, it's the same behavior. If we move any single controller, we'll have the corresponding lifting behavior. So this way, we can delete those helper controllers we created to help us understand. These two locators we created, let's put them in this group. This way, our exercise of using four corner controllers to control the model's lifting effect is complete. I hope this exercise can help everyone better understand the idea behind this effect.